Okay, in this lesson we're going to cover the angle relationships in triangles. The first one is the sum of all the interior angles inside of a triangle have to add up to 180 degrees. Now there's a couple of acronyms that can be used to display that knowledge. SATT, sum of an angle triangle theorem, or angle sum triangle theorem for ASTT. It doesn't really matter, those are just two acronyms that can display that let your teacher know that you understand where that angle came from. So let's find angle x. I know that all these angles have to add up to 180 degrees, so I can take 180 degrees, subtract the two known angles, 100 degrees, subtract 50 degrees, and that's going to leave me with, so I have 180 minus 150, that's going to leave me with a missing angle of 30 degrees, and I used the fact that they all have to add up to 180 degrees as my knowledge, so that is 30 degrees. The next one is Isosceles Triangle Theorem. For an isosceles triangle, you have two equal sides, and you also have to have two equal angles. Now the equal angles are, well actually I should say the angle that's different is the one that's between the two equal sides. So if my two sides are equal, these two sides are equal, that means that these two angles down here are equal, and the one in between the equal sides is the one that's different. So taking this example here, I have my equal sides. That means that x is the one that's different. I have 70 degrees. This must also be 70 degrees. And I use Isosceles Triangle Theorem to figure that out. And now I know that all three angles of a triangle must add up to 180 degrees. So I can take 180 minus 70, which equals 40 degrees. And I used my first angle theorem, SATT, to figure that out. Missing angle that was 40 degrees. For an isosceles triangles, you're going to have two angles that are equal as well as two side lengths. Okay, and remember all the angles of a triangle still add up to 180 degrees. Third triangle theorem is Equilateral Triangle Theorem. It can be called as an acronym ETT, Equilateral Triangle Theorem. Equilateral triangles, all sides are equal. And if all sides are equal, so are all angles. And if all angles are equal, they all have to be 60 degrees. 180 divided by 3 is 60 degrees. So if you have an equilateral triangle, you know that all the angles are going to be 60 degrees. The fourth triangle theorem is for an exterior angle theorem. And this works for not just triangles, but for any shape. You take the sum of all the exterior angles, they're going to add up to 360 degrees. Okay, so if I want to find the exterior angles, which are created by taking a line of a triangle and just extending it past the vertice, so taking this line, extending it, taking this line, extending it, those create exterior angles. And if I was to find them, so if I have 50 degrees, that means that this angle here is 130 degrees because it's a straight line. If I have 60, this exterior angle here is 120 degrees. And if I have 70 degrees, this exterior angle is 110 degrees. And if I was to add up all these exterior angles, 110 plus 130 plus 120, I add them all up, 0, 6, 360 degrees is what they all add up to. All the exterior angles add up to 360 degrees. And that's not just for a triangle, that's for any kind of polygon. Here's some examples. Let's find the missing angles. First thing I want to do, I know that all the angles in a triangle add up to 180 degrees. So if I want to figure out angle x is going to equal 180 minus 80 minus 70. Okay, find that missing angle, so that'd be 180 minus 150 is going to equal 30 degrees. That is equal to 30 degrees, and I used SATT, sum of the angle triangle theorem, to figure that out. And if that is 30 degrees, this is a straight line, which means angle y is going to have to be 150 degrees because those two also have to add up to 180 degrees. Here I have some exterior angles, and that's all I'm worried about, exterior angles. And I know that these exterior angles must add up to 360 degrees. So I'm going to have angle x is going to equal 360 minus 165 minus 145. 360 minus 165 minus 145 degrees. Okay, 165, 145, those add up to 310. So that's going to leave me with 70 degrees for angle X, and that was exterior angle theorem. And for the third example, I have an isosceles triangle. Okay, two angles must be equal. Now in this isosceles triangle, my equal sides and the angle between them, which is the one that's different, is 40 degrees. So I have 180 minus 40 degrees, which equals 140 degrees left to be split between these two equal angles down here. So 140 divided by 2 is 70 degrees. Both X and Y are going to equal 70 degrees, and that was isosceles triangle theorem, where those two angles must be equal, that I used. Okay, so we covered some angles involving triangles in this lesson. Thank you very much.